question essentially was all about, is it wise to purchase a hybrid vehicle or a gasoline-powered vehicle? What would be the wiser choice for me, for you? Okay? Say again?
Well, I gotta go with the Tesla because I have one, but
well, so
it's not the wiser.
Yeah, so we can get into like we did this project last year, and people will get up into yeah, but I like Teslas, or some of the people were like, well, yeah, but I could just buy like a brand new Lamborghini, Ferrari, or whatever, and that'd be the coolest. But we're going to have like kind of a limited number of choices. This is going to be kind of like a corporate decision-making process, and maybe a Tesla in some corporate situations would be good because of the mileage demands and the territory that you would be driving through. Actually, the Tesla might not be the better choice just from a practical standpoint. And so that's why we're looking at like gasoline versus hybrid in our project. So some things you're going to want to bring. Please listen. When we're fully in our project, you're going to want to have like a computer or a phone or something you can do research with, because you are literally going to be doing some original, actual, legitimate research. It's not going to be the teacher saying, now, answer question number 2, and like this scaffolded research that's not actually really research. You're going to be doing this yourself. So it's going to be about as real world as we can get it while still sitting in a classroom. Seriously. So it's going to be kind of fun. So that'll be kind of the rest of our, to be honest with you, that'll be sort of the rest of our semester up until like review for tests and stuff like that. Okay? Thursday. Yep, I'll be getting you guys in some groups. I'll get you the info on Thursday, and we'll be off and running.
Is this project worth the most?
It's worth the most of all the 3 projects we're doing this semester. The first one, let's see, our first project, or our second one was the initials.
Yeah. First one was like the property.
First one was the property posters. This one's worth the most. 100 points. So the posters are worth 25. Initials were worth 50. This one's worth 100. Yeah.
Will we have homework?
Okay. So the project is intended to be an in-class project. So like if you're staying on task in class, you shouldn't have a whole lot to do on the project at home. If you're, getting distracted or whatever, well then you might end up with a lot of project work at home. But the intent is that it would be done all in class. That's the intent. All right, so guys, this is going to be our lone example here today. This is going to be something that we will process over the course of weeks. So, as you guys leave here in about 10 minutes, listen up. As you all leave here in about 10 minutes, if as you leave you think, whoa, I did not fully 100% master that, that's okay. That is okay. I will be posting the video for this, and we will work on this again tomorrow, and the day after that, 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 so on and so forth. It'll take a little while for a lot of you to fully master this. Do your best. I think some of you might figure this out all the way today, but just know we'll take some time, so don't stress too much. So this is a paragraph. So whenever you've got a paragraph in a math question, I want you guys to do this. I want you to kind of remove yourself from the math classroom setting for a second, and I just want you to try to read this for meaning. I don't want you to try to figure out what the numbers mean or figure out what the answer is. I simply want you to read it as a story. And then after you read it as a story, we're going to try to draw a picture, like a GPS picture of this. I'll read it out loud for you. It says, a car leaves Rockford traveling toward Wausau at the rate of 55 miles per hour. At the same time, another car leaves Wausau traveling the other way towards Rockford at the rate of 50 miles per hour. How long will it take them to meet if the cities are 157.5 miles apart? So all I want you to do here is just read this and think about this as a story. I don't want you trying to figure out any answers yet. I just want you to think of this as a story. Can anybody, like in a very short, very brief thought, summarize this story? Just in 1 or 2 like quick sentences. What's happening?
2 cars leave Rockford at different speeds.
I don't think they both left Rockford.
One left Wausau and one left Rockford.
Yeah, one started in Rock. Oh, just show the hand motion again. Watch Mason. Do it one more time. So what are the cars doing? They're going towards each other. You saw his hand motion. He said this. The cars are they not?
Yes.
Okay, the cars are heading towards each other. So, wouldn't it make sense then if one car started here and the other car started over here and they head towards each other, wouldn't they meet somewhere in between? I'm not going to say meet in the middle. Why would they not meet exactly in the middle? Noah?
Because they're traveling at different speeds.
They're traveling at different speeds, right? One of them's going 55, the other one's going 50. Now, if they were both going 55, wouldn't they meet in the middle?
Yeah.
If they're both going 50, they'd meet in the middle, but one of them's going 55, the other one's going 50, so they will definitely not meet in the middle. So this is kind of the story, right? We're digging in, we're saying, all right, what is happening here? This is an actual story. Can we describe what's going on? So the next step is, let's try to draw a picture, a very rudimentary GPS sort of picture. Here's what I would do. I would say that this dot right here represents Rockford, so I'll just put an R for Rockford. And then this red dot over here represents this Wausau, where that is. And then the blue car does this. And the red car does this. And they will meet, as I've drawn with my picture, somewhere in between. Does this make sense?
Yes.
So all we're doing is we're treating this like a story. We're drawing a picture of it. And now we're going to get into some of the details. We're going to get a little bit more math involved. I'm going to call this blue distance. I'm going to call this distance 1. Like a D with a little sub 1. Call that distance 1. And then I'll call the red distance 2. And we might sometimes not use a 1 or a 2 there. We might have better descriptions. But right now I'm just going to say distance 1 and distance 2. Now there's one more thing I need to put on my picture. There's one more thing I know about these two cities. What is that one more thing that I for sure know?
There are hundreds.
Yeah, well, I know the distance between them. So I know that from here all the way over to there is 157.5 miles. So this next step for a lot of folks is the most challenging step. Maybe that won't be the case for you. What we need to do now is we need to take our little picture, our map, and we need to write down a relationship, also known as an equation. And this equation has one requirement. This equation has two requirements. It's got to use all those elements, but the main thing is, the requirement is, the equation has to be true. So can I give you an example of a false statement? If I said D1 equals D2, don't we know for certain because of what Noah said that that's false? So I did use some of the elements, but what I wrote was false. It was a total lie. So I'm not going to write that. Can anybody think of what could I write using all those elements in the picture and the statement actually be true? Bree, what do you think?
You put 157.5 equals 55x for one of the equations.
You're going too far. You're going too far for me.
Okay.
Just use the blue thing, the red thing, and the black thing.
Okay. That equals so D1 plus D2.
D1 plus D2. Let's stop right there, and we'll get to your detail level in a second. Do you see how that's true? If you take one little segment of the distance and you add it to the other little segment of the distance, you get the whole distance, right? Little part plus other little part gives you the whole thing. Nice job. That's right. Well done. Bless you. Okay, now we're going to go to the level of detail that Bree just was going to. And in order to do that, we need to remind ourselves of a relationship. Do you guys remember this relationship maybe from middle school? Distance is equal to rate times time. You ever hear about that in middle school? The distance that you go is equal to your speed, aka the rate. Distance is equal to your speed times your time, or your rate times your time. Okay, so let's fill in the details. We'll end up with a pretty easy equation to solve. Okay, so what is the rate of the D1 car? The one that starts in Rockford. How fast is that one going? That's going 55. So I'm going to replace or substitute. You okay with that? I'm going to substitute 55t in there for D1. What's the rate of the second car? So what could I replace D2 with? Say again? Distance doesn't equal rate. Distance equals rate times time. So I could replace D2 with 50t. There you go. 50 times t. Okay, so once you get to this point, you actually have a fairly easy equation you could solve. I would add my like terms on the right. And then how would I finish this?
You divide 105 by...
There we go. Dividing both sides by 105. That gives me t equals, I think it's 1.5, isn't it? So these two cars would meet in 1.5 hours. So since the question asked, how long will it take them to meet? 1.5 hours would be a reasonable answer to that. And we've answered, okay? Should we practice this for like a week and a half? Okay, that's what we'll do. Have a great rest of your day. I'm going to get your tests on the way out. So just have your Unit 2 tests, and I'll get those from you on the way out.